prime factorization, highest common factor, and lowest common multiple. In this part of the lesson, we will be looking at some of the following skills. Number 1, expressing an integer as a product of its prime factors, leaving the answer in index notation. Meaning we are going to do prime factorization. And followed by next, we will make use of the prime factorization, the skill that we know, to find what is the highest common factor and the lowest common multiple of some of the numbers. Let us take a look at some of the questions in our mentor series. So for example, the first question over here, express 4, 3, 5, 6 as a product of its prime factors, leaving your answer in index notation. Now we know that we have to express it as a product. Product means you have to do multiplication, something times something, right? And in of its prime factors, so we should need to do prime factorization by dividing the number using the prime factors. We should do in sequence the smallest prime factor first, and after which we need to leave our answer in index notation. Another word for writing index notation, index actually means the power, so index notation means the power form. Right? So how do we go about doing prime factorization for such a number? So we need our calculators to stand by. We have 4, 3, 5, 6. We're going to start dividing or doing the prime factorization by the smallest prime number. So 4, 3, 5, 6 can be divided by 2. And I'll get the number 2178. And you notice that it's still divisible by the factor 2, the smallest prime factor. So we're going to continue to divide this by next. Then now we shall try to move on to the next prime factor. Let's check if this is divisible by the factor 3. Yes, it is. So I'll divide it by the factor 3. Okay, and I get 363. And it looks like it's divisible by 3. I shall continue to divide by the smaller prime factors first, so 1, 2, 1, and this looks like this is a multiple of 11, so I'm going to try divide by 11, which gives me 11 again until I get the number 1. So the moment I have this, it will get 1 over here. I will end my prime factorization, and I know that this number 4, 3, 5, 6 can be written as a product of, is made up of 2 times 2, which is 2 to the power of 2, or rather 2 square, 3 times 3, which will be 3 square, and 11 times 11, therefore it's 11 square. Hence, I have expressed this number as a product of its prime factors, and I left the answer in index notation. Okay, so this is how we do prime factorization. But in examination, we may not have time to write all the working over at this side. So hence, we need to learn how to use the calculator wisely and take note of the factors as we do go along, okay, to do the prime factorization. Now, how do we use this skill for prime factorization to help us find the highest common factor? So let's move on to the next question. For example, down here, find the highest common factor of 1, 2, 6 and 5, 6, 7. The first thing that we need to do is express each of the following numbers, 1, 2, 6 and 5, 6, 7 as a product of its prime factors. So as I need to show you the working, right? But in exam, maybe you may not have time to do all the working over here, so you might want to learn to use the calculator wisely. So I'll start with 1, 2, 6. I'll do prime factorization. Always start in sequence by the smallest prime factor, so you do not miss out any prime factors. So divided by 2, that will give me 63. It's divisible by 3, right? Then this one will give me 21. Remember, we should always divide by the prime factors and not say, oh, I divide by 9 or divide by other numbers. Always use the prime factors. So the next one will be 3, and this is 7. Then until I reach 1. So this means 1, 2, 6 can be written now as 2 times 3 to the power of 2 times 7. Next, let us try out to work out for 5, 6, 7. I need to divide it by the lowest prime factor. 5, 6, 7 is an odd number, definitely not divisible by 2. So let's try with divided by 3. Oh, it works. So then I'll get 189. Not sure whether it's still divisible by 3. Check again, continue. Oh yes, it's divisible by 3 and I get 63. Right? Then we divide by 3 again. I get 21. Divide by 3 again, I get 7. Divide by 7, I get 1. So this means 5, 6, 7 can be expressed as 3 to the power of 1, 2, 3, 4. So 3 to the power of 4 times 7. Now I want to use these two prime factors methods to find the highest common factor. How do we find the highest common factor? The highest common factor is using the prime factors. We choose number 1, all the factors that are common. And we want the one with the lowest power. Okay, why is that so? For example, let's take a look at where are the factors that are common. The factors that are common throughout both the numbers, we know that both of them have a 3 and both of them have a 7, right? But this is 3 square, so it's 3 times 3. The other one is 3 to the power of 4, 3 times 3 times 3 times 3. What's the highest number of sets of common factors? So I have the first set that's common, second set that's common, no more. Nothing else is common already. So this is actually 3 to the power of 2. You'll notice out of power 2 and power 4, I chose the one with the lowest power. Okay, next one, this is 7 and 7, so it's the only one common set of factors, so that would be 7. Now question says find the highest common factor. They did not say leave your answer in index notation, so I'm not supposed to leave the answer this way. I will have to change it to 3 squared times 7, which is 9 times 7. That will give me the number 63. Alright, many of the students still try to do the listing method. That is for primary school. We no longer use that method in secondary school. Alright, so please take note. Okay, so now let's move on to one more practice question. Probably you'd like to try this as well before we move on to lowest common multiple. So what happens if I have numbers that are like that? Find the highest common factor for 36, 72, and 135. So the first thing, express each of them into a product of its prime factors. Now, most often than not, students say, oh, 36 is divisible by 6, so I just put 6 squared. Well, that is not correct because we're going to do prime factorization. We'll need to start with the smallest prime factor. So 36 divided by 2, that gives me 18. That gives me 9. Divided by 3, 3, and I get 1. Hence, I'll get this as 36 is made up of 2 to the power of 2 times 3 to the power of 2. Okay, and what about 72? In exam, you may not have time to do this, so you need to use your calculator wisely. You calculate or divide by 2, you get 36. Divide by 2 again, you get 18. Divide by 2 again, you get 9. Divide by 3, you get 3. Divide by 3, you get 1. So you get 2 to the power of 3 times 3 squared. And last but not least, 135. Alright. This one obviously is not divisible by 2. Then I'll move on to try the first, the next prime factor, which is 3, happen that is divisible by 3. I'm going to continue, and I get 15. I'm going to continue again because it's still divisible by 3, and I get the number 5, and number 1. Alright, so finally, this is made out of 3 to the power of 1, 2, 3, 3 to the power of 3 times 5. Right, so we have expressed all these numbers as a product of its prime factors. In exam, if you are able to use your calculators well, you may not even need time to write this working. But please indicate down here, I'm looking for the highest common factor. Let's take a look. Out of all these 3, 2, 3, and 5, which is the factor that is common throughout? I will have 3. Then which power should I choose? I have 3 squared and 3 cubed. How many sets of common factors are there? The first common factor, the second one. So this will be 3 to the power of 2. As the question mentioned, it's just the highest common factor, did not mention in index notation. So the final answer will be the number 9. Alright, so I hope you are clear with that already. With that, then we shall move on next to finding the lowest common multiple using prime factorization method. So how should we find the lowest common multiple? First step, let us express all these numbers as a product of its prime factors. So I have 56. I'll start with, it's an even number, so definitely divisible by 2. Continue, it will be 14. Then divide by 2 again. This will be until I get 1. So this will be 2 to the power of 3 times 7. Right? Exam, you may not have time to do all this. So do calculate on your calculator correctly. Next factor, next number 126. Obviously is divisible by 2. I get 63. Divided by 3, I get 21, sorry. Divided by 3, I get 7. Divided by 7, I get 1. So this is made out of 2 times 3 to the power of 2 times 7. And I want the LCM now, lowest common multiple. When I find the lowest common multiple, I must choose all the factors. I must include this common multiple must have all the factors of both the number. So I must take all the factors, and of course I will choose the one with the highest power so that it includes every single factor. Nothing is being left out. So all my different factors are 2, 3, and 7. Out of 2 cubed and 2, I'll choose 2 cubed so that it encompasses all the different factors. Next one, 3 only have a 3 square, so with of course they're going to be 3 square. And 7 is already both of them are 7 to power 1, so it's just 7. Okay, but in this case they just say find the lowest common multiple. They did not say leave your answer as a product of its prime factors. So I will have to calculate out what is this number using the calculator. So this number will be 504. Okay, it mentioned you are going to use the listing method. You probably need to do quite a few numbers to reach 504, right? So this one will be the answer. So no more listing method in secondary school, right? Next one, try one more question. Find the lowest common multiple of 48, 108, and 126. So I should go ahead and give the answers. So please try and get your factorization correct. Okay, so I already done my prime factorization, and this is the answer that I have. So you have to try it on your own. Then how do I find the lowest common multiple, the LCM? First, I must choose all the factors. I need 2, 3, and 7. I choose the one with the highest power, so that includes every single factor. So 2 to the power of 4, and 3 to the power of 3, and 7. Once again, they did not tell me to leave the answer as a product of its prime factors, so I will have to use my calculator to calculate out this particular number, 3024. Have you gotten your answer? Okay, now that we have already know how to find the basics for highest common factor and lowest common multiple, let's move on more extra step to finding questions that need us to use the skills for understanding the concepts on lowest common multiple, right? For example, in question 14a over here, find the smallest positive integer. Okay, some of you may not have learned what is positive or negative yet, but it just means it's a whole number. All right, positive integer means it's a whole number. Positive means they are positive numbers. There's no negative sign. All right, so the smallest positive integer meaning a whole number of n. what is this so special about this n? For which the 63 multiplied to n is a multiple of 49, right? The keyword here, multiple of 49. So I'm going to go through with you two different methods. One is the understanding of concept. The other one is the longer method to be sure that if you do not know how to do, you sure can get the answer. Right, so if I want to have these two numbers, first I'm going to look at 63 times n, right? So I'm going to look at factors of 63 first. So 63 can be expressed as 3 squared times 7. So expressed as a product of prime factors, this is the number for 63. Alright, now then 63 needs to be multiplied to a number, integer n. I do not know what is this integer n, such that this whole thing is a multiple of 49. What do you mean by the words multiple of 49? 49 is made up of 7 times 7, so it's 7 squared. So we know that 49 is equals to 7 squared. When I say this number 63 times n is a multiple of 49, it means all the factors of 49, which is 7 squared, must be included. So let's take a look at the number 63. 63 has 3 squared, but 49 don't have 3 squared. But that means 63, the 3 squared is something that's extra. That's okay. So we're going to leave it as that. We're not going to touch it. Okay. Then we look at the next factor. 63 has a 7 to the power of 1. So 63 only have one single factor of 7. But what about 49? 49 has 7 squared. It's 7 times 7. Right? So in my number 63, I only included one factor for 7. There's only one on its own. Something is missing. Right? I am short of one more factor. So in order to make it become 7 squared, to include that factor 7 squared, I need to multiply the number 7. So what is this n that I have multiplied? N is the number 7. So when you say it's a multiple of 49, all of the factors of 49 must be included inside. In this case, 7 for 63, there's only one factor 7. So I need to include one more factor and multiply it with the number 7 so that it can become 7 squared. Okay, so that factor can be included inside. So this is the first method. We have gotten the answer n to be equals to 7. So by observation, you observe what are the numbers or factors that are missing. Right? So this is the first method, method number 1. The other method that we can use is, let's look at the question. This is talking about 63 times n, then 49. So it actually involves two numbers. So I have the number 49, which is 7 squared. I have the number 63, which is 3 squared times 7. When you say it's a multiple and it involves these two numbers, 63 and 49, means I'm going to look at the LCM of 63 and 49. Since it's 63 times n, that means the LCM is equals to 63 times n. So let's find the LCM. What's the LCM going to be? The LCM is going to be, I'm going to choose all the factors with the highest power, all the factors with the highest power. Right? So they say this LCM is actually the 63n. But I do not want to know what is 63n. I want to know what is n. So how do I change from 63n to n? I need to divide by 63. You can either use the calculator or you can divide by the factors directly. So I'm going to change a little bit of my working here. Right? I'm going to find what is n directly. So I'm going to divide by 63. What are the factors of 63? 63 is 3 squared. and 63 times 7. So times 7. When we do division, we can cancel out the factors. What can we cancel out? 3 square with 3 square, exactly the same, cancel out. 7 square is 7 times 7. Then divided by 1, 7 below. I can cancel out 1 pair, right? So I'm left with, technically speaking, I'm left with just the number 7. So n will be equals to 7. Okay, so both methods will be able to give us the same answer, just that they work slightly differently. Alright, we should try one more question. Okay, next one. Find the smallest integer, integer means a whole number, p, such that 42 times p is a multiple of this number. Right, again, it's talking about multiple, but they say 42 times p. So I will look at the shortcut method. I'll look at 42 first and p. So what is 42 made up of? 42 divided by 2, divide by 3, and divide by 7. So 42 is made up of these factors. And I need to have a p. I don't know what's the p. Such that all the factors... What are all the factors of this number? 2 times 3 times 5 are included. Let's see one by one. First one, 2. Is there already a 2? Yes, this factor is taken care of. So do I need to multiply anything? This is 42p, right? 42p means 42 times p. So do I need to multiply any 2? No need, it's taken care of. Next one, I have 3. But this one is 3 square. Short of 1, I only have 1. So short of 1 more, I need to include 1 more inside. Then there's a factor 7. 7 is something extra. It's okay to have extra for this case. And then the other one, but the other factor is 5. So 5 is not inside. I need to include the factor 5. Alright, and this one will give me the value for p to be equals to 3 times 5, 15. Alright, this one is one method. Now we can try the other slightly longer method by no observation, okay, by the lowest common multiple method. So let's take a look. If I want this number, 42p, multiple of this number, it means I'm going to look for the LCM of these two numbers. So I have 42 is 2 times 3 times 7. And I have the number itself, 2 times 3 square times 5. So I should try to find out the LCM first. LCM includes all the factors, 2 times 3, factors with the highest power, so 3 square, 5 have to be inside, 7 have to be inside. And this LCM is actually 42 times p. Question, how do I find p? I do not want the 42. If I want to find p, I do not want the 42, means I need to divide away by the factors of 42. So I'm going to divide by 42. Where are the factors of 42? We have 2 times 3 times 7. So divide by 2, 3, and 7. When we do division, we can cancel out. Then you'll be left with 1. Right? 3 square and 3. This is 3 square. This is 3. So we cancel it away. We are left with 1 single 3. Then 5, nothing to cancel. I still left with 5. 7 and 7 can cancel away. Then I'm left with p to be equals to the number 3 times 5, 15. Alright, so please take note of such skills, different skills for this question. Okay, I hope you have gotten the answer. Now with that, we'll move on to the next part, the last question. A combination, how would they combine the questions together as one whole question itself? So for example, they will in question 18, they will give you two numbers itself, right? You have m and you have n. I want the largest. Largest, is it related to highest or lowest? So it should be related to highest, isn't it? Factor of both. Means both of them also have the same factor. Means what? Means it's actually talking about a common factor. So if that's the case, I'm just going to look at the highest common factor. So I have m, 3 cube, 2 square, 5 square. And I have another letter n, 2 to power 4, 3 cube, 5 to power 4. I want the highest common factor. Highest common factor. You choose whatever that is common only. So, well, we have common. And you choose its highest common factor, but you choose the lowest power. Sure, how to choose the lowest power when both of them have the same power? Both have the same power, you choose the same power. Okay. Then the other one is 2 square and 2 power 4. So you choose the lower power. Okay, if in case you cannot remember, this is 2 squares, 2 times 2. Right? So how many sets of common factors do we have? We only have 2 sets. So it's 2 power of 2. Next one, 5 square and 5 to power 4. You choose the one with the lowest power. So 5 square. Okay, read out for the question. The question did not say leave your answer as a in index notation. So hence, I do not have a choice. I have to calculate out what is this number, find the value of it. And it gives me the number 2700. Right? Okay. Next part of the question, now you notice they never tell you LCM as well, but how do I interpret or find the answer? Find the smallest. Smallest is related to highest or lowest, so this one will be the lowest. Okay, multiple of both the number m and n. So this is actually talking about common multiple. And they say leave your answer in index notation. So I need these two numbers, and for those of you who are good in your mental sums or you're good in observation skills, you can choose not to write this down like that. You can choose not to write it this way. You can just straight away give me the answer. Okay, no problem. Exam, you can save some time. Right? So when you want to choose lowest common multiple, we choose all the factors. I will personally prefer it to be written from smallest to largest, so we can rearrange later. Okay. Lowest common multiple, you choose all the factors but with the highest power, so that every factor is included. So you choose the highest power. 2 square and 2 to the power of 4, I must include all the factors. So only 2 to the power of 4 will be able to include all the factors. Same thing, 5 to the power of 4. And the question say, leave your answer in index notation. For me, I just prefer to rearrange it. So therefore, my answer will be 2 to the power of 4, 3 cube, 5 to the power of 4. I prefer to rearrange it from in order small to big. Okay? So it means the same thing, but the way the question is being phrased, you need to get used to the way that it's being stated. Right, last part. Find the smallest integer d such that m multiplied with d is a multiple of n. So complicated. Let's write this down one by one. M multiplied to d. So we got m and d. M is 3 cube, 2 square, 5 to the power 2, 5 square. D I do not know, but they say multiple of n. That means n is all the factors of n, which is 3 cube, 2 to the power of 4, 5 to the power of 4 must be included. Let's check one by one. 3 cube. 3 cube. Is it included? Yes, it's included. Alright, everything. So 3 cube, that one also have 3 cube. So all is included. Now this is 2 to the power of 4. But here only have 2 to the power of 2. How many factors are missing? I need 2 more factors too, right? So I'll have another 2 square. So that I'll get 2 to the power of 4. Here have 2, then add another 2 more to give you 2 to the power of 4. Next thing, this is 5 to the power of 2, only have 5 times 5. I need 5 to the power of 4. How many more do I need to add? I need 2 more factors, right? So it's 5 to the power of 2. So therefore, what is D? This is the number for D. But the question, did they tell us to leave in index notation? No, right? So hence, I need to write down D equals to, calculate this, 2 squared times 5 squared. And I get the answer, 100. Have you gotten the answer? Now, with that, we come to the end of this part of the chapter. We'll see you again for the next lesson.